Looks good. Alright, so first I have to figure out what I want to learn first. I think I should just run through that book. Just make sure that I have it. I do not. Now that I think about it, it should be in my drive. Just gonna show you what I'm doing. Oh, I know I should be in good notes. Books. The machine learning book. I feel like that's gonna take most of my time. Do work through all the products. Make sure you understand every bit. Answer your questions. Take notes of any it's like any sort of any curious about. And then this is I should do this. So now that it's downloaded, let's see now. There we go. Google Collab. I think I should first review all the things that I've done so far. Google Drive. check. Let's go straight to it. Yeah, it's definitely chapter 2. So initially, we wanted to get the data, so we used the pathlib the pandas to export the dataset into a CSV through this. Then we used that path. Import tar file, interact with tarvals, open, and then URL lib to make requests to online. Man, I should really learn all these things. Maybe I should create it myself. So basically, the objectives of getting the data would be to get the URL of the dataset, retrieve it, extract it, convert the data set into CSV. Why do we need to convert it to CSV? Which data type, which file type is easier to parse with machine learning? Semi-structured data? What's semi-structured data? Information that contains both structured and unstructured formats with elements not organized. So semi-structured data is more So when you parse image files, you would want to use OpenCV pill. Python image library. So differences between pill, OpenCV, and TensorFlow. What are the differences between these for image modeling? OpenCV is for real-time computer vision applications. And then I guess this is for image manipulation. Oh, this is easier for basic tasks. Quick prototyping, image pre-processing, machine learning. I guess the next level, the final level, would be TensorFlow, but initially I want to learn Pill and OpenCV. I think I'm gonna stick to OpenCV for now, and if I have to, I'll move on to TensorFlow, because I don't really need to learn Pill unless I'll be testing around. Yeah. Librosa would be used for audio files. Python libraries for different types of varying ML domains. So okay, well, initially for images, it would be OpenCV, Pill, and TensorFlow in order of difficulty. And then for audio, it would be Librosa, spectrograms. So it would be loud in around the 5th frequency at this time. Okay. What's this? Interesting. So there's this. So a binary file format, unlike plain text from CSV or JSON, is encoded in a more complex way. It's encoded in a more complex way, not being shown or edited using a simple text editor. What about MPZ? see. So these two are just compressed formats for larger data sets to save storage and have the ability to optimize the machine learning model. That would be, for both of these, it would be TensorFlow PyTorch. Storing slash loading. Yeah, okay, back to this. So convert the dataset into CSV and then assign it to dataset into variable. Okay, so I'll just do that through VS Code. Just a random folder, I guess. IPY and B, I think. Please. B. Yep. Okay, so initially I import pathlib as path, and then import not tensor, tar file, and then import no, this urllib, and then I want to convert the dataset into a CSV using pandas as PD, and then I just assign it to a variable. So def in input dataset. I'm assuming I just need to put the URL. So the path, input path would be equal to path of, let's just put it, yeah, just C, right? This is C, right? This might not be C. I think it's D. Yeah. Yep. D downloads. And then I guess retrieve dataset, and then that would be okay. So first, what I messed up is that it should be the folder and then the naming of the path. So the name of the path. So what do they call it? Housing. TGC. for this. I did URL, but I need to URL request to make it a little more efficient, but I guess that's fine, right? Yeah, it should be fine. If not tarbile is file, so that would be in case that the file already exists. So if not input path exists, pause. Is file. Is file. I would retrieve the data set through so there's no input since I'm just going to be inputting it in the code source. URL equals so it's if is underscore file. The more you learn. This is from the path library. Then I think this one made a folder called datasets, which makes sense, I guess. But so in this case, I'm in a different folder over here. I don't know where exactly, but I think I should find out where the file is. In that case, I guess I will make a folder like that. So in path, make a directory. Make a directory called datasets? Is that what this does? What does this do? Okay, so that's two. Got it. Parents equals true. Exists. Okay, equals true. That's the case, right? Exist, okay. URL request, URL retriever. So once I request the URL, how do I know that this is the next thing? Using the tarball path? I guess it does save to that variable. Interesting. Request. That it would be URL and then input pen and then with tar file dot open input path as housing dataset housing dataset dot extract all into path equals datasets, something like that. Underscore path and then return pd dot read CSV of housing dataset. Yeah, and then housing would be equal to input data set. Oh. I mean, I guess I'll just... Okay, yeah, I guess it extracted into that, but why is there the housing? Oh, it's because it's from that folder. Okay, I see. Okay, let's try it. Module object is not callable. So like that. Input path is let me see whether this actually works. Huh. So I did do something wrong. Try this again. Type error. There's a line numbers in here. easy. Okay, it's not. Yo, I need a def checker. Oh my goodness. Why do I not see the difference? Okay. Yeah. Yeah. With open. It might be because of the tab. Yeah, it's because of that. Let me delete this to make sure that that's not actually the issue. Oh, 뭐야? Okay. Let's just can make it like that so that we can tell the difference. Okay, there we go. Oh, nah, ain't no way. I called it you a retriever, not you a retrieve. Oh my god. Bruh. Wait, so that's the only issue, right? So if I did this, it would not have any issues. Oh my god, that's annoying. Okay. Anyways, I think I kind of understand that side of things. So, move you back here. Wait, what am I doing? I guess 1, 2. Analyzing the data structure. So you could do head, info, describe, and then specific table information. Okay, visualizing graphs, example, histogram, creating a test set. Okay, let's just do that now. Give me another table, please. Okay, so housing head. So they got latitude, longitude, house median, total rooms, total bedrooms, population, households, and ocean proximity, and median out. That was weird. Interesting. Housing. Min. What if I did this? My bad. Min? Oh, okay. My bad. I'm pretty sure there's a way to parse through this. Parse through. Right, I use loc to locate. So dot loc. Let's say min. Population of 3 is crazy. Population of 35,000. Total rooms. I guess that would be like for a certain county or area. The value is 500,000. Wait, what year was this data set made? Whatever. Let's see. So housing. Specific table information. How did I do that? Right. Oh yeah, since it's a what's the term? It's a table that doesn't have a number. It's the only object value. Okay, so I guess yeah, I could just do valued accounts housing. And that housing variable, what type of variable is that again? It's a CSV file. Okay, so housing ocean proximity value counts. Interesting. And then visualizing it through graphs. I was this random piece of code that I don't need to worry about. I'm just gonna do a histogram through CSVs. Actually, no, I don't think I need this. So this is this one. This one has an outlier over here. Something that is skewed. These two are skewed to the right. We can have one having an outlier. What does PLT.show do then? What's PLT then? PLT. Ah, I see. So I guess I do need that. Alright, so I guess I did all that. So now I do questions. This is just rough. Running through each chapter like this. I think I should have a session where I just read after I run through all of these. I think I want to read the next chapter. Yeah. I'm gonna be to be continued. To be continued tomorrow in creating the test set. And then I can take notes on chapter 3, which is about classification. My favorites. Okay, so else did I learn? Um, um, file types used for modeling. I was definitely struggling a lot with that part when I was trying to retrieve the data sets. Python modules used for different types of of learning archetypes. Archetypes. No. Okay. I think that's about it. Was I missing something? So let's just read on classification. In chapter 1, I mentioned the most common supervised learning tasks are regression, predicting values, and classification, predicting classes. In chapter 2, we're explaining regression tasks, predicting values, and then so now we're going to get into classification using various stages. And now we will turn our attention to classification systems. MNIST. To download popular datasets. So MNIST, what is it? A dataset of 70,000 small images of digits handwritten by high school students and employees of the U.S. Census Bureau. Huh. So the sklearn.datasets package contains mostly 3 types of functions. Fetch, such as function fetch OpenML to download real live datasets. Load to load small toy datasets bundled with scikit-learn so they don't need to be downloaded over the internet. And make to generate fake datasets useful for tests. Generated datasets are usually returned as X, Y, tuple containing the input data and the targets, both as NumPy arrays. Both datasets are returned as sklearn utils bunch objects, which are dictionaries whose entries can also be accessed as attributes. They generally contain the following entries: a description of the dataset, input data, the target. Okay. The fetch OpenML is a bit unusual since by default it returns input as a pandas data frame and the labels as a pandas series. Unless data is sparse, but the MNIST dataset contains images and data frames are not ideal for that, so it's preferable to set as frame as false to get the dataset as NumPy arrays instead. Interesting. Huh. So it'll be a NumPy array of zeros and 255, I believe. 1,000 images. Each image has 784 features. What? Oh, because each image is 28 by 28. Because 28 times 28 is 784, I guess. Oh. Let's take a peek at one digit. Take a peek at one digit from the dataset. All we need to do is grab an instance feature vector, reshape, and display it using map.ly item show. We use cmap cap binary to get grayscale color, where 0 is white and 255 is black. So plot digit, some digit would be that x0 is the data right here. There's 70,000 of just an array of zeros. Okay, so it would be a ton of zeros for that digit, and then it would be reshaped as an 28 by 28, and then showed as an image with the cmap binary for the grayscaling, and then axis off. What does that mean? Let's see. So, what is an axis? Ah, I see. Okay, it's just a visualizing thing. Okay, so that makes sense. This looks like a 5, indeed the label tells us that it is a 5 using y, which is target data. So, okay, those are the variables. Okay, you just give the complexity, show a few more images, but wait, you should always create a test set and set aside before inspecting it closely. So I think the test set needs to be bigger. It should be a 60-40 split. Oh wow, they're doing this way bigger split for a test. Okay, that's completely fine. We don't want one fold to be missing some digits. Some learning algorithms are sensitive to the order of the training instances, and they perform poorly if they get many similar instances in a row. Shuffling the dataset ensures that this won't happen. Ah. Huh. Interesting. Training a binary classifier. Let's simplify the problem for now and only try to identify one digit. For example, the number 5. This 5 detector would be an example of a binary classifier, distinguishing 5 and non-5 query vectors. Good place to start is with a stochastic gradient descent. One at a time, which makes it most suited for online learning, as you will see later. Now we can use the detect image of the number 5 to predict array true. Guesses that a 5 is true, looks like guess bright, blah blah blah. Performance measures. Evaluating a classifier is often significantly trickier than evaluating a regressor. So we can spend a large part of this chapter on this topic. There are many performance measures available, so grab another coffee so we can cover a bunch of new concepts and acronyms. Okay. I'll be ready for that, but let me first see how many pages there are for this chapter. Damn, bro, how long is this chapter? 236. So about 100 pages. 와, 진짜로 미쳤다. Oh my goodness gracious. Okay. A good way to evaluate a model is to use cross-validation, just as you did in Chapter 2. Let's use the cross-val score function to evaluate classifier model. Hold on. Alright, it's been a full hour. We hit 1 hour. I think we got a lot of learning done, which is good. I think I'll have do 1 more hour of work, and then I'll call it a day. Alright, lock in, lock in, lock in. Okay, a good way to evaluate a model is to use cross-validation, just as you did Chapter 2. We use the cross-val score function to evaluate our SGD classifier model using k-fold cross-validation with 3 folds. Remember that k-fold cross-validation means splitting the training set into k-folds, 3, then training the model k times, holding on different fold each time for the validation. Wow, above 95% accuracy on all cross-validation. That looks amazing, doesn't it? Well, before you get too excited, it looks at the dummy classifier. You use classifier every single combination in the most frequent class, which in this case is the negative class, which is non-5. So if you always guess that an image is not 5, you get it right 90% of the time. This demonstrates how accuracy is generally not the preferred performance measure for classifiers. Interesting. So accuracy is generally not the preferred performance measure for classifiers. Especially when dealing with skewed data sets. When some classes are frequent than others. A much better way to evaluate the performance of a classifier is looking at the confusion matrix. Better way to evaluate performance of a classifier. basically what it does is count the number of times instances of class A are classified as class B for all A-B pairs. So, example, what? To know the number of times the classifier confused images of 8s with zeros, you would look at row 8. What about for columns that are non-numeral? Okay, to compute, I guess I'll just have that question. Confusion matrix. How does it react to non-numeral features? To compute the confusion matrix, we first need to have a set of predictions so that it can be compared to the actual targets. Okay, yeah. So it's just basically saving the predictions made by the training model. But it says to keep the untouched for now. Remember that you want to use this test set only at the very end of your project once you have the classifier that you're ready to launch. Instead, you could use the cross-val predict function. Just like the cross-val score function, cross-val predict performs k-fold cross-validation, but instead of returning the evaluation score, it returns the predictions made in each test fold. This means that you get a clean prediction for each instance in the training set. By clean, meaning out of sample, the model makes predictions on data that never saw during training. Represents an actual class, while each column represents a predicted class. Why is it so big though? The first row considers non-5 images, the negative class. So 53,000 were correctly classified. While the remaining 687 were wrongly classified. Okay. The second row considers the images of 5s, were wrongly classified as 5s. While the remaining 3,500 were correctly classified as 5s. The perfect classifier would only have true positives and true negatives. Interesting. It gives you false positives and it also gives you false negatives. Okay, type 1 error. Type 2 error. Okay. The confusion metric gives you a lot of information, but sometimes you may prefer a more concise metric. An interesting one to look at is the accuracy of the positive predictions. It's called the precision of the classifier. So precision would be true positives divided by true positives plus false positives. So it would be this plus this divided by these two added. So precision, yes. So precision is typically used along with another metric called recall. So okay, false negatives is of course the number of false negatives. Ba 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 ba. Scikit-learn provides several functions to compute classifier metrics, including precision and recall. Now, our 5 detector does not look as shiny as it did when we looked at its accuracy when it claims an image represents a 5. It is correct only 83% of the time. Moreover, it only detects 65.1% of the 5s. It is often convenient to combine precision and recall into a single metric called the F1 score. Especially when you need a single metric to compare two classifiers. The F1 score is the harmonic mean of precision and recall. Interesting. So, but it's a combination of precision and recall into a single metric. It's the harmonic mean. Whereas the regular mean treats all values equally, the harmonic, while the regular mean treats all values equally, the harmonic mean gives way to low values. So classifier will only get a high F1 score if both recall and precision are high. Okay, so take a screenshot. What? Hmm. That is odd. I think we should close this so that we can look at how it looks. The dev console. Um, hmm. 429 error. Oh, I did not know that was possible. Okay, then in that case, I'll just do anonymous. Uh, Imgur. Let's see. Vacation name. Bob. What? Yeah. recon score favors classifiers that have similar precision. Precision and recall. This is not always what you want. Sometimes you must care about precision and other classifiers. Really care about recall. For example, if you train a classifier that can be stress good, you want to prefer a classifier that rejects any good videos. But it keeps only safe ones high precision, rather than a classifier that has much higher recall but less few really bad videos. Should we, in such case, we even want to add a human pipeline to check the classifier's video selection? On the other hand, suppose you train a classifier to detect shoplifters in surveillance images. It is probably fine if your classifier only has 30% precision, as long as it is 99% recall. Sure, the security guards will get a few false alerts, but almost all shoplifters will get caught. Unfortunately, you can't have it both ways. Increasing precision reduces recall and vice versa. It's called the precision recall trade-off. The SGT classifier uses a threshold equal to 0, so the preceding code returns the same result as predicted. This confirms that raising the threshold decreases recall. The image actually represents a 5. The image classifier detects it when the threshold is 0, but it misses it when the threshold is increased to. So, what is the difference between prediction and prediction? Let's go chat. What is in machine learning? What is the difference between prediction and recall? Oh no, not prediction. Precision. Precision and recall are two different metrics used to evaluate the performance of machine learning models, particularly in classification tests. Both metrics help access how well a model is performing, but they focus on different aspects of the model's predictions. Precision measures the accuracy of the positive predictions. It is the ratio of true positive predictions to the total number of positive predictions made by the model. Yeah, uh-huh. The accuracy is how well the model captures all the actual positive cases. Mm. So precision is the accuracy um, based on the total positive predictions. It's the accuracy of the total positive predictions, but the recall is the actual, or like how well they captured the actual positive cases. But then precision is based off of um, the. Oh my. Okay, that makes sense. I think. Okay. Trade-off between precision and recall. This is often a trade-off. Improving one usually comes at the cost of lowering the other. High precision, low recall. The model is conservative in predicting positive cases, leading to fewer false positives, but more false negatives. This is suitable when you want to minimize false positives. High recall, low precision. The model predicts more positive cases, leading to fewer false negatives, but more false positives. This is suitable when you want to capture as many positive cases as possible, even if it includes some incorrect positives. So, high precision is basically um, making a lot more things positive, but wait, oh, this is really. Oh, yeah. High precision is to make sure that you have less false positives, but high recall is when it predicts more positive cases, leading to um, more false positives, but fewer false negatives, which gives less of a chance of making um, what is it, type 2 errors, since type 2 is a little worse than false positives. So it's dependent on how well, or like in which direction you want to sway towards. Okay. With these scores, use the precision recall curve function to compute precisions and recall for all positive threshold. The function adds less precision. The last recall of 1 corresponding to an infinite threshold. What are these thresholds? I'm still not understanding this. What are thresholds in thresholds in machine learning? Decision boundaries determine how a model interprets its output, particularly in classification classes that are often used in models to produce probability or scores. The threshold decides how these scores are converted into final class labels. In binary classifier models often output a probability score between 0 and 1, indicating the likelihood that a given instance belongs to a positive class. A threshold is a value that determines how this probability is translated into a class label. What's a class label? Ah, I see. Okay, so threshold is set to that anything above a zero point 0.5 confidence or probability, it is considered positive. And then what is an infinite threshold? And also, what is this metric based off of? Because it's not a percentage. Decreases recall. How do you decide when the threshold is used? With these scores, use the precision recall curve. Blah blah blah. Blah 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 blah. Finally, use matplotlib to plot precision recalls. Let's show the threshold of 3000 we selected. So as the threshold continues to change, we want to hit the that point right there. I am assuming, right? Threshold. The reason is that precision may sometimes go down when you raise the threshold. Although generally it will go. To understand why, look back at figure 34 and notice what happens when you start from the percentage node, which is 1 to the right. On the other hand, recall can only go down when the threshold is increased, which explains why the curve looks smooth. I think I needed something. Can you provide an analogy? Precision recall. Engineer span filter is a bouncer whose job is to allow this inside positions like more cautious. Fewer mistakes. More suspicious. More prone to giving positives. Possibly more okay, that makes so much more sense. Holy cow. So precision, it's going up as we increase the threshold, since it's being more cautious and recall is like, what are these numbers? Okay, whatever. Oh man. I'm burnt out. Holy cow. Suppose you decide to 90% precision. You could use the first plot to find the threshold you need to use, but that's not very precise. Alternatively, you can search for lowest threshold that gives you at least 90% precision. For this, you can use numpy array argmax method. This returns the first index of the maximum value, which in the case is the first true. So, I guess this is the new threshold. Yeah, I don't know why they didn't do that before. To make predictions, instead of calling the class members predict, you can run this code. I'll check the predictions, precisions, and recall. Okay, sure. Recall. um, pause. So, isn't precision better though? I see. Precision doesn't mean that you're actually getting the right ones through. Precision is okay. Man, this is confusing. Alrighty, the rock curve. The receiver operating characteristic. Rock curve is another common tool used with binary classifiers. It is very similar to the precision slash recall curve, but instead of plotting precision versus recall, the rock curve plots the true positive rating. Another name for recall. Against the false positive rating. Also called fallout. The ratio of negative instances that are incorrectly classified as positive is equal to 1 minus the true negative rate. That makes sense. It's 1 minus the false positives. 1 minus the true positives. Or true negatives. Correctly classified as negative. It's called specificity, hence the raw curve plot sensitivity recall versus 1 minus specificity. To plot the rock curve, you first use the curve function to compute the TPR and FPR. Then you can plot the FPR against the TPR using matplotlib. The polycode produces the figure corresponding. Once again, there's a trade-off. The higher the recall, the more false positives. Yeah, that makes sense. Rock curve stays as far away from that line as possible. Interesting. One way to compare the cloud model is to measure the area under the curve. Alright, let me play some live music.
I can deal with no emotion. Been wasting all that to devotion.
16 words.
I'm cashing short off all the notion. Is this a dream or just illusion? Shit. Knife cold, cheap nose. I can tell she's kryptonite. Lost in her dose, but I'm getting out tonight. There is no us, that is a no-go. And now I guess I'm going solo. I can't even tell she's gone. The writing's on the walls, don't say it anymore. Yeah, I can't even tell she's gone. No echoes in the hall, can't hear them anymore. No, I can't even tell she's gone. The writing's on the walls, don't say it anymore. Yeah, I can't even tell she's gone. No echoes in the hall, can't hear them anymore. No, you can't keep all your commotion. I've been around, yet did I mention someone you know from recollection? It's not a dream, not a delusion. Shit. Knife cold, cheap nose. I can tell she's kryptonite. Lost in her dose, but I'm getting out tonight. There is no us, that is a no-go. And now I guess I'm going solo. I can't even tell she's gone. The writing's on the walls, don't say it anymore. Yeah, I can't even tell she's gone. No echoes in the hall, can't hear them anymore. No, I can't even tell she's gone. The writing's on the walls, don't say it anymore. Yeah, I can't even tell she's gone. No echoes in the hall, can't hear them anymore. No. I can't even tell she's gone. I can't even tell she's gone. No echoes in the hall, can't hear them anymore. I can't even tell she's gone. No, knife cold, she knows. I can tell she's kryptonite. Lost in her dose, but I'm getting out tonight. There is no us, that is a no-go. And now I guess I'm going solo. I can't even tell she's gone. The writing's on the walls, don't say it anymore. Yeah, I can't even tell she's gone. No echoes in the hall, can't hear them anymore. No, I can't even tell she's gone. The writing's on the walls, don't say it anymore. Yeah, I can't even tell she's gone. No echoes in the hall, can't hear them anymore. No.
Okay, let's just write down some more things.
Tell me that you notice, got me getting roses, trying to make it something, yeah. Got me down on Friday, now I'm up on Sunday. I'm already missing you. Girl, you be my antidote. Get close to what you're waiting for. We could do it on the bedroom floor. There's something about your love. Your love, yeah. You got me, your love, yeah. You got me, your love, you got me something about your love. Got me open, I'll be coming back for more. Come to break and shit, you work and never keep it score. Body perfect, I'll drink you like a chemical. Something about your love. Ain't no issues, blame it on the alcohol. Nothing hurting all week, better take a fall. Love the way you move and you got me doing this. Something about your love. Baby, you got a lot up on your mind. Baby, you know I'll be on your side. Said if you give me one sign, but all night I gotta be hanging out. You're singing down, music singing bomb. I know what you like, get a tongue tie. Win this for life, win this for life. There's something about your love. Yeah. You got me, you got me, you got me something about your love. Got me open and I got you at the door. Got the perfect shit working booty on the door. Body perfect touch, it'll tip and I know something about your love. Ain't no issues, stabbing up to my door. Telling us I know I'm good, got my on the door. Love the way you move, bitch, your body, girl. There's something about your love. You got me, your love, yeah. Something about your love. Don't let nobody say you're psycho. Even when you're on a tightrope.
Algorithms that just support
They don't know that it's a pain for something else. What a shame they couldn't paint it on themselves. Take a second on me. It's a habit when it's old. When you get up in the middle of the night, feel like you're losing control. You know I'm never gonna be like, but you feel right. I get there, fighting for you. You get my vibe, like no one else before you. Yeah, you feel right. There's just something about you. You're my type. You're my. Don't you think I noticed that you've been keeping that distance? Yeah, you know I don't mind if you can. With you, I feel like I am blinded. Yeah, we go dumb, da da dum dum. Feel so faded now. We've been down, da da dum down, and now I'm walking on a tightrope, waiting for you. But it's a habit when it's old. When you get up in the middle of the night, feel like you're losing control. You know I'm never gonna be like, but you feel right. I get there, fighting for you. You get my vibe, like no one else before you. Yeah, you feel right. There's just something about you. You're my type. You're my, but you feel right. I get there, fighting for you. You get my vibe, like no one else before you. Yeah, you feel right. There's just something about you. You're my type. You're my.
What is this? It predicts 45. They train 45 binary classifiers to create an array of 10 scores for some digit.
Saw you leaning over the counter. Your drinks not getting any colder. You've been here over an hour.
So
It's like I'm waiting for an answer. Head tangled up in a flower. Caught in a daze is your power. slow, like a swig in the low. Head tangled up in a flower, caught in a daze is your power. Thinking of getting it closer. My heart is yours to devour. Could it be your Messiah? Looking at you is my golden hour. I'm drowning in your ocean. Come save me from the open. What you providing got me excited. Now you left me all confused. Girl, you got me loose. Can't even blame it on the juice. Now I'm breaking all the rules, yeah. You can call me Dr. Seuss, yeah. Ain't no running throughs, yeah. Girl, you got me loose. Can't even blame it on the juice. Now I'm breaking all the rules, yeah. You can call me Dr. Seuss, yeah. Ain't no running throughs, yeah.
Oh my god, wait, this might just be what I need. Pose, multi-person pose estimation.
So look, I used to swim competitively, and I absolutely hated it. I remember that at the end of every single lap, my coach dropped the confidence threshold. If we look at this aspect ratio, so remember the longer side of this 352.
So basically, just running. I'm trying to create a project where it collects as much information as possible. Tennis, so I need to figure out how to detect certain key points of person's body part. So like the elbow, the arm, the shoulders, the back, hips, knees, all that. So I think this video would be super.
And let's try that again. Got some weird detections over here and over here.
Now I'm getting nervous like I used to
This
get.
would be helpful.
Asking you to
Here, but that's fine.
the word and I'll be on the way.
Pretty cool, right? So you can see the impact of changing our scaling, right? It obviously performs a
Still be able to identify those values when backhand, when my forehand moves and my backhand switches to both of my hands.
But if
Will
you
it
find
be
yourself
able to
awake
define
at
which
2
one is the left
a.m.
and which one is the right?
a lot better. We can close out of this. Let's actually try using a different image
I think this is a good video.
or a different video. So rather than using tennis, let's actually try the soccer one.
So let's not complicate.
So that's with our soccer images, and I think the soccer video is the same shape, so that's why we don't need to adjust our scaling. We're getting
We can solve them down the line. And if you feel the same, I hope you won't get tired of me. Do my best to offer something new to you. You don't need to doubt that I'll be true to you. I promise if you say the word, and I'll be on the way. Let's just go talk about it. I got time if you're about it. If you need me, I'll be here to stay. Let's just go talk about it. I got time if you're about it. Say the word, and I'll be on the way. Let's just go talk about it. I got time if you're about it. If you need me, I'll be here to stay. Let's just go talk about it. I got time if you're about it. Been a while since someone made me feel this way. Been a while since someone made me feel okay.
Sexual violence targeting images and coherent impulse, simultaneously detecting and localizing interesting points of the image, also known as interest points or spatial points.
You mean same thing, maybe let it talk good. Coming back around, making all this shit feel good. It could make you wild up till you can't breathe. Got me messing in my jammies now I can't see. Yeah. Stuck in a 9 to 5, caught up as this shit's a waste of time. Ain't got the appetite. space. Feel my legs get looser. My mind's open to the future. This feeling I just can't replace. Hear it burn it up and turn now, and I'm out of time. Just move, babe. Put on your shoes, babe. Get on the move, babe. We're running loose. Hey, I'm ready to move, wait. Got no excuse, babe. I'm on the move, babe. And nothing to lose. Hey, you ain't thinking, maybe that it's all good. Coming back around, waking up, shit feel good. Could make you wanna move when you can't breathe. Got me messing in my dreams and I can't sleep. Yeah. Take you to paradise. Gotta be moving, just don't think twice. No time to compromise. Looking for reasons to feel alive. 200-300 degrees. We on a mission to disappear. Remember to hold on tight. Sit back, relax, and enjoy the ride. I'm floating up out of space. Feel my legs get looser. My mind's open to the future. This feeling